So are you taken?
You bet your bottom's dollar I am.
No, I'm much stronger than that oxygen chick that you have.
Oh, I might have to reconsider then.
Well, it is just me, or do you feel a connection?
Almost as if we have chemistry.
Well, I'm recently single.
Then let me replace you.
By the way, what is your name?
The name's Bond. Ionic Bond. Okay, so I'm pretty sure we all know what ionic and covalent bonds are. Wait, some of you don't? Well, before we get to what they are, we need to talk a little bit about something called valence electrons. Valence electrons are the electrons in the highest occupied energy level of an element atom. The number of valence electrons hugely determines what the chemical properties of that element will be. The easiest way to find valence electrons is by looking at the group it's in. 1A has 1, 2A 2, 3A 3, and so on and so forth until we reach group 8, which contains 8 valence electrons, except for helium, which holds 2. This is because helium is in the s block, which can only hold 2 valence electrons.
So the reason why the most amount of valence electrons an element can have is 8 is because of something called the octet rule. The rule itself is too complicated for me to put into words, so I'll quote directly from the textbook. In forming compounds, atoms tend to achieve the electron configuration of a noble gas. The reason why they do this is because 8 electrons is when the element is in its most stable state. What I like to remember is after Miller's 8th cup of coffee, he is in his most stable state.
Cations are positively charged ions. They are produced when an atom loses valence electron to follow the octet rule. If we looked at the periodic table on the left, at the alkali metals and at the alkaline earth metals, these will be the most common cations. If we looked at lithium specifically, this metal really wants to become helium so it can become more stable. So it loses a valence electron to become stable. Because it lost one valence electron, it becomes a positive ion. This means beryllium would need to lose 2 valence electrons to become stable. Anions are the same thing, but negatively charged, and on the other side, fluorine would need to gain 1, oxygen 2, and so on and so forth.
So when it comes to actually forming an ionic compound, you take an anion and a cation and put them together. There are a couple of rules needed to be followed though when it comes to bonding them together. First, if it makes an ionic compound, it is bonded, ionically. Second, the cation had to be a metal and the anion has to be a non-metal. Third of all, and finally, the charges of the ionic compound has to be neutral, or 0. So like 1 positively charged ion and 1 negatively charged ion, or 1 charge of +2 and 2 of -1, so on and so forth.
Now, if you're like me and don't automatically know what ionic compounds produce in this world, but you still want to know, is this an ionic compound? Well, this is how you tell. Ionic compounds are crystalline solids at room temperature. Now, to the average human in this world, I bet you're asking, what is a crystalline solid? Well, it's just a solid that is arranged in crystal formations. But to stay basic, just think a solid at room temperature. Ionic compounds also have high melting points. If an ionic compound is melted or dissolved in water, it can conduct electricity.